Hello, everybody. Being from southern New Hampshire, I think it's really great to see a conference like this come to New England. So I'd like to start off by saying thanks a lot to Steve, Brett, Adam, and Alan, and everyone else who put this great project together. I mean, this conference has been fantastic so far. So thanks a lot, guys. So lately, I've been doing quite a bit of front-end work with Ember.js and back-end development with Rails. And in the process, I've learned a bit about the APIs that come between them and what works well for the front end, the back end. And I'd like to share a bit of what I've learned with you today. I've developed a bit of a checklist for whether your application needs an API in the first place. If your front end is written with a JavaScript application, like Backbone, Angular, or Ember, you're going to need an API. If you're writing a native app for mobile or for the desktop, you're going to need an API. And if you're integrating with third-party services, you're definitely going to need an API to keep that cloud happy. If you want your app to be scriptable, you want to keep these guys happy too, so you'll need an API. So it's really as simple as that, and I would say most apps these days do need APIs. Today, we're going to build an app that does. Called it Ruby Pets, inspired by this great conference. We want Ruby Pets to be one of the leading platforms for the pets of Rubyists. Ruby Pets was inspired heavily by Pete Brown's Ruby Cats site, created as an Ember Rails demo, and undoubtedly the leader in this market segment. So. We're gunning for you, Pete. So, luckily for me, my cat Cashew has told me she's going to manage this project so I don't screw it up. Our requirements are, we'll need a dynamic Ember front end. Of course, we'll need mobile apps, integration with services in our segment. Ember Pets definitely needs an API. Yes, Cashew, a RESTful API. So let me start off with a very brief primer on RESTful APIs. Your application's nouns are modeled as resources. For Ruby Pets, that means our pets, people, and a few others. Every resource has a URI. Pets can be located at /pets. Each pet can be located at /pets/ an individual unique ID. The same pattern for people. Resources are acted upon with HTTP methods. The 5 big ones are post for creating a new resource, get for retrieving a resource, update for updating a whole record, patch for updating a part of a record, and delete for destroying that resource. There are others, but these are the ones you'll use most of the time. Cashew comes back and says we're going to need an ambitious RESTful API because we've got so much on our plate with this project. So what would that comprise? Would be flexible. Since we need to support multiple clients, it's going to be difficult to predict their needs, especially third-party services. Let's provide broad access to data so that clients can decide what they need from each request. In order for it to be usable, we want our API to be consistent. We need it to be internally consistent so that each resource can be accessed in the same way. We also want it to be consistent with the expectations of our clients and their tools. We should follow RESTful API conventions as much as possible. Efficiency comes along with flexibility. Allowing users flexibility to request precisely what they need makes for fewer requests, less bandwidth, and faster responses. Of course, we'll need to secure our service. We don't want anyone besides the NSA to access our private data. Ideally, we should provide meta information in our responses that will make our API as easy to browse as the web itself. Is there anything we won't do? When looking at these industry trends, I think it's a safe bet to stick with JSON as our data format and skip XML. All right, so we'll roll up our sleeves. Let's get started. Seems pretty intimidating, right? So let's start simple. Always a good place to start. Let's create a new Rails project and scaffold out some of our resources. We've got pets and their toys to start. We're going to migrate our database, set a default route, do some miscellaneous stuff, and we will have our models defined like so. We'll have pets and their toys. A pet has many toys, and a toy belongs to pets, to a pet. We'll have controllers, a pet's controller, a toy's controller. This is all the default scaffolded Rails output, with Rails 4, that is. So you can see the index action corresponds to the get of all, and we're just returning the pets array, and that will be rendered by our view. By default in Rails 4, JBuilder's included to render JSON, and the top part of this slide shows rendering of the index view, and below that is the show view. We're basically, in the index view, we're looping over the pets and extracting their name and a URL for each pet, and below we're extracting other attributes for that pet. The output of each call would be this JSON, an array of JS objects. Here we've got the two pets in there are my cat and my dog so far, and there's an instance of querying the API for a single resource, the Ginkgo, my dog. Now, if you look a little closely at these two outputs, you'll notice that the representation of the resources in the array is slightly different from the representation of the resource when it's shown on its own. Right from the bat, we're aiming for a consistent API. And why is there this inconsistency? The views, of course, are rendered individually. We've got multiple custom representations of the same resource here. And this could be a maintenance headache as our resources evolve and appear in multiple places. This approach also limits the kind of flexibility we can offer clients without heavy customization of each view. For instance, if we wanted to allow customization of each resource based upon a request made in action, then we'd have to and we wanted to generalize that across each representation of the action. Well, it would be a lot of customization. And I don't think that all of this customization is helping us too much in the long run. In the spirit of Rails, let's look for some conventions to eliminate these. The JSON API project looks like a promising solution. JSON API is a hypermedia type for JSON APIs. What does that mean? It's basically a spec that defines how APIs should define their resources and URIs, as well as how they respond to HTTP methods. In some places, it's strict, and in others, it's more flexible. It's even got its own MIME type, which was registered by Steve Klabnik just a couple weeks ago. Ooh. But this is still a work in progress. So this is either good or bad, depending upon how you look at it. On the good side, it's still being formed. It's not a hardened spec. And so all of us who have an interest in this topic have a chance to shape it to some extent. There's a GitHub project for JSON API. And there are plenty of issues, and it's being formed as we speak. I'd encourage anyone who's interested to check those out. Of course, on the downside, we can't just use it right away and have no expectations of change. However, looking a little deeper, we see that the primary editors of this spec are Steve Klabnik and Yehuda Katz, who, of course, have pretty great records with open source. So I've got a pretty high degree of confidence that this will work out and get some good traction in the community. So how are we going to implement this? There are some example implementations of this that are out there with varying degrees of compliance as the spec itself is moving, of course. For our particular implementation, Ember data lines up nicely with our Ember UI. And it works very well out of the box with a Rails project, a Rails gem, active model serializers. So let's roll with those for Ruby pets. Let's see how that goes to start. Going to the GitHub page, we can see that active model serializers promises to encapsulate the serialization of our models. Seems like that might solve some of the problems, the consistency issues we saw earlier. So let's try it out. So in our gem file, we're going to comment out JBuilder. We're going to add active model serializers. We're going to bundle, install, generate some serializers for our two resources. This is the result. They look pretty close to the models we have. We have attributes that we want to serialize for each one, just an ID, a name, and timestamps. We'll need to update our controllers we're only interested in rendering JSON. We don't need to use respond with because we're not responding to multiple MIME types here. We're just creating a JSON API. So we're going to just render JSON, pass in our resource. Our active model serializers is hooked up so that it will know that resource needs to be rendered with the corresponding serializer. So for the pet model, it will be the pet serializer, and of course it will work with arrays or individual objects. So the output now for just a simple request to pets is an array of objects, and they're nested underneath the pets key. So that's a little different from JBuilder's output. And similarly, for the singular object, it is just pet. There has been a recent change in JSON API in which singular and plural resources are returned with the plural form. But that change has not made its way into active model serializers. I'm not positive it'll stick, but we'll see going forward. Remember, we're at a bit of a moving target here. So So anyway, let's go with active model serializers. It's been released. And another thing we can notice about this output is that the representations of each resource are identical. Here, the dog Ginkgo is represented in both places with an ID name and created at and updated at timestamps. So that makes the boss a little happier, but she still wants clients to be able to decide which fields are included. We want some customization. So let's put this through the paces. We're going to look at how we could do that with a serializer. Apparently, you can override a method, include plus the attribute name with a question mark, and that will allow for custom inclusion of a single field. So if we wanted to, say, pass in an option for whether an individual field's included, you might pass in a hash with fields plus the key of the field itself that you're checking. So this is how you could customize inclusion of a single field, the created at field. Now, it's nice you can do that, but that's pretty verbose, not very dry. So we're just dealing with Ruby classes here. So let's create a base class, a base serializer, and inherit from that with our pet and our toy serializers. In our base serializer, we can now override the include question mark method, which is used to determine the inclusion of any field. And in this case, we're also going to be checking the options that are passed in. Check that field hash, but then it's going to be keyed upon the field name. And so this will generalize the approach to apply to any field, so that that options hash with fields can be passed in to customize the inclusion of any field. If it's not passed in at all, then all the fields will be returned for each serializer. Let's get into relationships. Remember, a pet has many toys. In the serializer corollary, it uses the same method, has many. And the output by default is this JSON. Again, it's all nested under the pet key. We've got toys now embedded in the pet, and we have our two toys that Ginkgo has. For a one-to-one relationship, the serializer doesn't care whether where the foreign key lies. It just knows that one object is hanging off the other. So you can just use has one regardless of whether you're dealing with a belongs to or has one relationship. So we've actually introduced a new resource here, person, in which a pet belongs to a person. I'm sure that many pets would dispute that. Exactly. Maybe I got them backwards. So anyway, that's represented here again by that has one relationship. Now, the output for the dog Ginkgo, who's serialized here, now includes a person. That's me. Okay, cool. So it all lines up. Now, let's take a look at returning an array of pets. Again, these are both my pets, and so they're both going to include myself as the person embedded in each pet. Duplication, not very efficient. So let's see what we can do about that. Let's go back to our base serializer. Now we're going to flip around how our resources are serialized by embedding the IDs of the related objects and in each resource, and including the associations alongside the resources. So we've got if the same query to pets now returns individual arrays of, or separate arrays of toys, people, and pets. The associations are kept in for each resource as an array of IDs. And you'll see that this can eliminate duplication in our output. So although I'm the person for both Cashew and Ginkgo, I'm going to only be included once in this output. Now, this is a pretty trivial example, but you can imagine with a verbose API, like say, a Twitter user might have 100 fields. So saving multiple representations of that user over many records can save both client and server resources and bandwidth. So we've been pretty deep in the trees. Let's step out a little bit and take a look at the forest of API design. Maybe a jungle, I don't know. So traditionally, RESTful APIs filter data with progressively more specific URIs. So to retrieve cats or dogs, it would require 2 different requests. But it's a nice, clean API, and it works well with any number of APIs out there now. Another approach would be to use a parameter that filters that data based upon the same base URI of pets. So this seems like a little bit of a step backwards in this case because we've taken a clean API and made it a little bit messier, you could argue. However, it's also a little more flexible, and because you can now combine conditions and so you're combining conditions in your filter, and instead of making 2 requests, you can make a single one to, say, include both cats and dogs. I guess that would filter out that one poor guinea pig, right? You can also, of course, combine conditions this way, and you're really querying your resources. So here we're not only querying by type, but also by color. So how about including relationships, which we've also touched upon? Well, most APIs now take a best guess at what resources are, they know which resources are related to each other, but they take a best guess at which ones should be included with a particular endpoint. And for example, if we're querying pets, we always want to return toys and the person along with them. Well, another approach is to not include any of those associations by default, and instead only include associations as requested. So provide an include parameter and specify the associations you want returned. We've also looked at embedding data. Remember, that was the default when we serialized our resources with JBuilder views. Another approach which we've seen already is to favor sideloading, but I wouldn't say it's actually absolutely forbidden from a design standpoint when you're taking this approach to embed data, but you would certainly never want to embed data records that won't be shared. So if there are concepts that exist only within a particular silo that are never going to get out of that, then I would see that that could work for your API. A rather controversial topic with API design is whether to version your API. Two alternatives, of course, are to do it or to not do it. Profound. So there are a lot of things to consider here. I would say that the vast majority of APIs are versioned, of course. And it's pretty difficult to argue against versioning when we're talking about a spec, that's JSON API, which is in transition right now. But really, that's the whole point of the spec. And once it is solidified, then you can comply with that, and maybe you won't. And it will be future-proof. But
you laugh, but what version of JSON are you using?
There's the maintainer right now. Steve asks, what version of JSON are you using? Touche. So yeah, it's a sticky one. So, and I would say, like I said, it is rather, the pragmatic approach most APIs take is to add versioning. I can see it being rather ideal to always, to stick with one representation of your resources. Of course, it depends upon your individual project and how solidly you feel you can define those. The idea with versioning is that you can have a sunset period for one version while you introduce another, and of course you're not maybe committing to supporting the old version forever, although that really would be compliant with not breaking the web. So that's a good thing. Okay, so we've also already touched upon sparse field sets. Traditionally, resources are returned with all of their fields. We've already shown that you can provide custom sets of fields by specifying them as a parameter. So that's how this kind of request would move through the controller and turn into that fields option that I showed earlier. So how would this work when you combine it with the concept of, say, including associations? So now we're customizing our returned fields as well as which associations you want returned. So we want to include toys and people, but we also want to, say, specify the fields for each one of those records. So we could prefix those with the resource name. Sorting, of course, APIs have to take a stance, have a default sort order, but you can also specify a custom sort order, ascending or descending. Pagination, I guess some arguably naive approach would be to have no limits on resources. Another approach typically used by most APIs is to provide a default page size, a max page size, and allow for custom requests of pages. I just want to point out here, throw in my opinion while I'm standing up here, that pagination is one of those issues that brings out the importance of a primary resource. With side loading, all of the resources are returned together. One approach to this problem would be to include only the primary resource at the top level and nest the associations under another key. So that's currently not on the books in JSON API, but there is an issue out dealing with this, and I think that might be an improvement. So getting into the nitty-gritty of pagination, there is an RFC 5988 that specifies you should return a link header to allow for navigation. This allows you to easily, the user, the client of the API, to easily navigate among back and forth between those resources, between, in this case, pages. So you could specify to first, last, next, previous, and then grab that header to find the next URI. So this actually feeds in nicely with the concept of hypermedia APIs, which Steve Klabnik's a champion of, and with good reason. A hypermedia API makes, this is actually a good TLDR written by the man himself. So I had a version just before the break that he tweaked just a little bit, but made it a bit better. So this hypermedia API makes full use of HTTP and a hypermedia content type to be as navigable as the web itself. So it actually lines up pretty nicely with Roy Fielding's original concept of REST, but the arguably pragmatic APIs that have come out that call themselves REST since then aren't in line with this definition. So that's why a new term was needed. So I'd highly recommend Steve's PDF on this topic. It's not too long, so no reason not to read it. It's a really good read and will get you thinking about it even if you don't plan on fully implementing a hypermedia API. I think there's a lot of good food for thought, and he rather fairly balances the pros and cons of this approach. Obviously, it's hypermedia APIs are a bit more scalable and future-proof, but on the downside, they're not as efficient and perhaps perhaps you're trading off some efficiency for discoverability. So it looks like I'm a minute over, so I'm going to launch into the security section with a brief history of OAuth. I wouldn't do that to you guys, not at the end of the day. All right, let me give you the TLDR. Of course, you need to restrict access to your resources to particular users as appropriate, and that could be handled in your controller and serializer layers. Use HTTPS. Keep your data secure across the wire. Use token-based security. And if you're bold enough to want to build an OAuth provider, don't go it alone. This gem takes on the problem pretty well, but it does implement a slightly older revision of OAuth. But James Coughlin is very responsive. So I don't know about you, but Cashew and I are beat. So I think it's time to say thanks a lot. Appreciate it. If you have any questions.